In this video, we are going to talk about what you need for the final exam. So I would suggest watching this video more than once. I would suggest taking notes. And remember, you can use a note sheet, so that this is a perfect way that you can get your notes started and in order. So let's take a look. Now, you are going to need to be able to convert between different types of units. So make sure you understand how to convert your units, write them in your conversion charts. First example we're going to look at is metrics, which uses powers of 10. I'm going to show you how to do this problem in two different ways. So our example is to convert 2,980 milligrams to kilograms. Now, if we have 2,980 milligrams, and we want to know how many kilograms it is, one way is to use our kittens hide down under dad's car motor chart. Now this is milli, this is kilo, so it goes kilo, hecto, deca, the plain old unit like gram, meter, liter, deci, centi, milli. Okay. So if we are going from a milligram to a kilogram, how many jumps does it take and in which direction? So we've got to go 1, 2, 3, 4, 5, 6 jumps to the left. So all I got to do, what's great about that little chart, is we take our decimal places. If you don't see it, it's at the end. And we're going to jump 1, 2, 3, 4, 5, 6. Now, we don't have anything there, so you're going to put zeros and the dot, and we want the front zero always to show for clarity. So our answer is 0.00298. And you can include the last zero, it doesn't really matter for that part. Okay. So that is one way to do this. Now another way to do it is to use your conversion factors, and that's a perfectly legitimate way to do it. Let me show you that way. Okay. So the first thing we know is that a gram is 1,000 milligrams. So you can use a proportion. If 1 gram is 1,000 milligrams, and then how many grams is I'm sorry, I'm jumping ahead of myself. 2,980 milligrams. Well, this is only going to get us to grams. So again, to solve a proportion, cross multiply. So we get that 2,980 equals 1,000x, which tells us we have to divide by 1,000. And so we get 2,980 divided by 1,000 is 2.980. Now that is grams. We have to go all the way to kilograms. So now we're going to use this conversion. So we know that 1,000 grams is 1 kilogram. So 2.980 grams is how many milligrams? So again, we're going to cross multiply and then divide. So we're going to get 1,000x equals 2.980. So x is 2.980 divided by 1,000, which is that 0.00298 that we saw earlier. And so you can use our conversion factors, but that kittens hide down there to dad's car motor does it very quickly, especially when you're going from milligrams to grams and grams to kilograms. Okay. Here's another one. This time we're going to convert 20 meters to feet. Now, if we go from meters to feet, the metric conversion from meters to yards, we're going to use that first, and then we'll use feet to yards. Okay. So 20 meters is how many yards? If we know that 0.9 meters is 1 yard. So again, cross multiply. And so we're going to get 20 equals 0.9x divided by 0.9. So 20 divided by 0.9 will give us, remember, that's yards, so this will be yards. So 20 divided by 0.9 is 22.222 repeating. Okay, I'll put a little bar over top to mean it's repeating. I'm going to leave that in my calculator so that I can do it. So I now have 22.22 repeating yards. Now I know that every yard contains 3 feet. So if 3 feet is 1 yard, then 20 goes on the bottom. 22.22 repeating is how many feet? So you can see that we're going to multiply by 3, and then that's going to be our answer. So if we multiply that by 3, we get 66.66 repeating feet. Now, let's say that they want us to round to the nearest tenth. This number is a 6. Behind it is something more than 5. So it's going to become a 7. And that's why we get the answer 66.7 feet. So there is one where we have to go from meters to yards first, and then from yards to feet. Now, one way you can think about a yard is 3 feet. So if you say that 3 feet is 0.9 meters, that is a conversion you can use rather quickly. Let's do another one. They say that we have 3 feet 2 inches and we want that to go to centimeters. Now we have 2 facts. A foot is 12 inches and an inch is 2.54 centimeters. So we're going to take 2 steps to solve that problem. Now 3 feet and 2 inches. Let's take that and discover how many inches total it will be. If 1 foot is 12 inches, then 3 feet would be how many inches? You can see very clearly we're going to multiply 3 times 12 because we're going to cross multiply, and we're going to get that is 36 inches. But we have to add that 2 on because we have 2 more inches. So that would be a total of 38 inches. So we're really taking 38 inches and turning it into centimeters. So 38 inches is how many centimeters? If we know that 1 inch is 2.54 centimeters. So you can see we end up multiplying. Anytime you're converting from something larger to something smaller, you will end up multiplying. So you'll see here 38 times 2.454 would give us how many inches it would be. So if we throw that into a calculator, 38 times 2.54, that's where we get the 96.52 centimeters. But please make sure that you look at, hey, how did they ask us to convert it to the nearest tenth, then the nearest hundredth, when you go to do that. Let's do another one. 50 pounds, 7 ounces to kilograms. So if you know that 1 pound is 16 ounces, and that 1 pound is 0.45 kilograms. The relationship there is between pounds and kilograms. So you can also even say, since a pound is 16 ounces, that 16 ounces, it is 0.45 kilograms. Okay? So 50 pounds is how many ounces? If we know that 1 pound is 16 ounces, that we're going from that larger unit pounds to that smaller unit ounces, we will multiply. 50 times 16 is 800 ounces for that 50 pounds. But we have 7 more. So we have a total, let me write the word total so we can keep track of things. That total is 807 ounces. So if we know that 16 ounces, a pound, is 0.45 kilograms. Then 807 ounces is how many kilograms? So we're going to do two things. We're going to cross multiply here. We're going to cross multiply here. So we get 16x equals 807 times 0.45. Now my calculator reads two decimal places. I'm going to leave it like that. And then I'm going to divide off the 60. So the 363.15 divided by 16 is 22.69687 kilograms. If we rounded it to nearest tenths, the 6 is followed by something more than 5. Let's take that and make that a 7 instead. Okay. There are more than one ways to do this problem. I'm showing you kind of the way that occurs to me and the way that I think is most efficient. That doesn't mean anything, but yeah. Let's do another one. Now we want to give a dose to our patient of 5 milligrams per kilogram of weight, and the patient weighs 100 pounds. So the first thing we need to know is the dose is related to kilograms. How many kilograms is this patient? So if 1 pound is 0.45 kilograms, then 100 pounds is how many kilograms? And you can see we're going to multiply, and then that's going to be the answer because it's going to be x exactly. Okay, x times 1 is x. So 100 times 0.45 is 45. And so if they weigh 45 kilograms, 5 milligrams per 1 kilogram, how many milligrams per 45? You can see very clearly we're going to multiply by 5. And logically, think logically, for every kilogram, I got to give them 5. There are 45 kilograms, 45 times 5. So 45 times 5, the answer would be 225 milligrams need to be given to the patient. Let's take a look at this one. It says that the dose is 50 milligrams per kilogram. The patient weighs 75 pounds. Medication comes as a liquid in 20 milligrams per milliliter. So we would want to know, yes, how many milligrams to give to the patient, but also how many milliliters would be the liquid that would deliver that amount of medication. How many milligrams is loading in, how many milliliters, and so on. So what we're going to do is similar to the last problem. First, we're going to use that 0.45 kilograms is equal to 1 pound. So 75 pounds is how many kilograms? If we know that 1 pound is 0.45 kilograms. Let me just make sure that I'm going to, yep, okay. And now, again, cross multiply. So 75 times 0.45 is 33.75 kilograms. Okay, so that's how much the patient weighs. We're going to give 50 milligrams per kilogram. So first, let's find out the dose. So if we're going to give 50 milligrams for 1 kilogram, how much are we going to give for 33.75? And logically, you can see cross multiply. Okay, so 50 times 33.75 is 1,687.5. Okay. So we need to get into this patient's body 1,687.5 milligrams of the medication. But the medication comes in 20 milligrams per milliliter. So that's 1 milliliter. I always put the 1 there just to remind me what I'm multiplying by. So 1,687.5 milligrams will be how many milliliters? So we want to know how much liquid needs to go into the patient. So again, you can see 20 times x, you can write that as 20x, equals 1687.5 times 1, which is just 1687.5. And then we're going to solve it by dividing by 20. Anytime the x gets multiplied by something other than 1, you're going to end up dividing by that value. And if we divide by 20, we get 84.375 milliliters. And you need to give your patient 84.4 milliliters of medication. So sorry, that was labeled wrong. Okay. Let's do another one. Here, it's a conversion by a formula. So this is the formula you definitely want to have written on your paper. So I would definitely write this down. So to convert Fahrenheit to Celsius, we're going to take the Fahrenheit minus 32. We're going to divide that by 1.8, and that's going to give us the Celsius. So if we have 87 degrees Fahrenheit, the 87 has to go right there. So we're going to get 87 minus 32. We do that first. That's what that parentheses indicates. And then we're going to divide by 1.8. Well, 87 minus 32 is 55. Divided by 1.8. Now watch how they're going to ask you to round. The calculator's saying 30.55 repeating. And if we round that to the nearest tenth, that would be 30.6 degrees Celsius. Okay, so rounding. Be very careful on the location. I know that some of you have some difficulty with rounding. Tenths with the TH would be here, but tens would be here, so be careful, okay? This says 100, so you want your answer to say 1200, 1400, 500, okay, so if that helps. That's different than hundredths, okay? So the nearest 100, here's the 100 mark. If behind it is 5 or more, which it is, we're going to take that number and make it up, go up by 1, and then we're going to put zeros in the other spot. So that's 12,900. See how we say the word 100 at the end. But hundredths is here. 100 has 2 zeros, so it's 2 places after the decimal point, hundredths. And that 5 behind 3 means 3 needs to become 4. So that's why we get 12,857.64 hundredths. So if you said the word correctly using, what you learned back when you were younger, you would say hundredths. We don't always say it correctly, but that's 64 hundredths. Okay. Greatest common factor versus least common multiple. Remember, the greatest common factor is the largest number that will go into the two numbers that you see. So it's smaller than, or at least as big as the smallest number. But the least common multiple is the smallest number that they can go into. So it'll always be a number that's equal to or bigger than the numbers you see. So it's kind of the wording, it's weird. So greatest common factor is something that can divide into the both. So what do we have to do? Well, we need to break these down. So let's look at our first pair of numbers. I noticed that this number here is even, both even. So I would first cut them down by 2. So 34,020 divided by 2 is 17,010. I noticed this is still divisible by 2. So as long as it's even, I divide it by 2. Now, if it ends in 5, I know it's divisible by 5. So this 8,505 is divisible by 5. So I got 5 and 1701. Now, 1701 is a weird one. It ends in a 1. If something ends in a 1, I usually will try 7. Or I might try 17. It is divisible by 7. And then I'm going to try another 7 again. 7 didn't work again. So then it's odd. The digits 2, 4, and 3, if you add them up, 2 plus 4, 6 plus 3 is 9. And that's numbers divisible by 3. So it's going to be divisible by 3. So if we divide by 3, 243 should divide by 3 nicely, and that's 3 times 81. I'm right out of a room. 81, I'm going to do it up here for a minute, and then I'll break this down easier. 81 is 3 times 27, or 9 times 9, which is 3 times 3 times 3 times 3. Okay, so that number right there is 3 times 3 times 3 times 3. So we have 2 2s. You can give me a little room here. So I have 2 2s, a 5, a 7, and I have not only this 3, but 81 breaks down to 4 more 3s. So I have 5 3s. And then I always just check my logic on a calculator. 2 to the second times 5 times 7 times 3 to the 5th should give me my original number. It does. Great. Okay. Now let's break this one down. Now I know that this is divisible by 2 because it's even. The last number is even, the number can be divided by 2. So that is 2 times 1,617. Now, if you do the same trick, 1,617, 1 plus 6 plus 1 plus 7 is, let's see, that's going to be 15, which is divisible by 3. So I know that that's divisible by 3. So if I divide that by 3, I get 539. 539 is not divisible by 3. So the other numbers I saw earlier were 7. So I'm going to try 7. Maybe I could put a 7 in there. They did. That's 7 times 77, which is 7 times 11. Okay. So that number, I'm going to write over here. So 3,234 is 2 times 3 times 7 squared. Now we're looking for what they have in common, and the greatest common factor actually uses the least number we see in any one location. They have 2's in common, but the least we see is one of them. So we can only use one that they have in common. They don't have a 3 in common. They do have a 7 in common. Oh, they do have a 3 in common, sorry. They have a 3 here and a 3 here, but the smallest is just one of them. Sorry, that's what I get for not putting them in order. And then I have a 7. The smallest amount is to the first power. So our first power, we can only use one of those. And then our greatest common factor, we'll just multiply those things together. So 2 times 3 times 7 is 42. You should check. 42 is divisible into both of the numbers. They should divide into it evenly, and that's the way you can check your work. Okay? Well, let's do it again. Now, this time, we're going to find a least common multiple. So different. You still want to see what's living in there. I noticed both numbers are divisible by 5. They both have 5 on the end. So that's the first way I'm going to go with these. 375 divided by 5 is 75, which still ends in 5. So divide by 5 again, and you get 5 times 15, which still ends in 5. So divide by 5 again, and you get 5 times 3. Okay, so I know that 375 is 5 to the third power times 3. Okay, let's do it for 525. 525 and 5 is divisible by 5, so to divide by 5. You get 5 times 105, which is divisible by 5 because it ends in 5, so divide by 5. Now, 21, hopefully that's just a fact you know, that is 7 times 3. And then I'm going to try to avoid the mistake I made earlier by putting them in numerical order Well, I'll keep the 5. So that's 5 squared times 3 times 7. But go in order, which I didn't, and that can cause you to miss something. Okay. Now, at least common multiple has to use everything they have to the highest power that you see it in any one location. So they have 5's in common. The highest power is a 5 cubed. They have 3 in common, but it's just 3 to the first. And they have a 7 in common. So the least common multiple should be 5 to the third times 3 times 7. Well, 5 to the third times 3 times 7 is indeed the 2,625. You see listed there as the answer. Let's take a look at some word problems. It says 10 students are ordering textbooks. 5 bought the used books for $35, $34.95. The other 2 options were the ebook of $18.95 and the new book of $64.95. Approximately how much was spent? Well, if we know that 5 each spent the $34.95, and it says approximately, let's make that 35. And 5 times 35 is 175. Okay, so we know for sure 175 is spent. Now, the other 2 options were ebooks and a new book. Okay, so we don't know what the other 5 have bought. So if you average this one being 19 and this one being 65, 19 plus 65 is 84, divided by 2, somewhere in between is $42. So the other 5 spent somewhere around that average of $42. 5 times 42 is 210. So 210 plus 175 is 385. So we don't know what he spent, but approximately how much you think was spent would be something close to 385. The answer would be B. Here's another one. It says a car rents for $159 per day with a mileage charge of 75 cents per mile. How much was a one-day rental with 300 miles? So we know they had to spend the $159. They also spent whatever 300 times 0.75 is, because that's the mileage charge. 300 times 0.75 is 225. So if you add those up, you get 389. So I'm sorry, 384. If you add those up, you do get 384. 159 plus 225 is our answer. Let's talk about fractions. Some things you're going to need to know about fraction are converting between fractions and mixed numbers, adding them, multiplying, and dividing. So make sure that when you add fractions, if they have a different denominator, you must have a common denominator. For multiplication and division, you don't have to have that. So I will show you that as we go through the section about fractions. So the first one is to convert 3 2/5 to an improper fraction. So the rule of converting to an improper fraction is you always take your denominator times your whole number and then add what you get on to your numerator. So multiply and then add. 3 times 5 is 15. So we're going to multiply. And then we get 15, and we're going to add. Now you're going to keep that denominator 5. We're going to add that 3 times 5 is 15 plus 2 is 17. Okay. Now to go the opposite way, if we're going to convert 18 over 7 to a mixed number, it's a division problem. This is an old school division. How many times does 7 go into 18 without going over? 7 goes into 18 2 times. So we multiply 2 times 7 is 14. And so to take off 14, we have a 4 remainder. So the 2 is how many wholes we had. 7 went into 18 2 times. The numerator is always your remainder. I had 4 remaining. The 7 stays where it is, just like the 5 stayed up here. The 7 stays there. Excuse me there. Now let's talk about adding fractions. Add fractions. I do not write them like you see here. Okay. Now you should have a fraction button, and I'll show you how to do it on decimals, because I'm pretty sure most of your tests you'll be able to do on decimals. So 5 9 plus 17 or 20. Okay. First thing we need to do is we need to find the least common multiple of 9 and 21. That would be 63. To change 9 into 63, we're going to multiply by 7 on top and bottom. To change 21 into 63, we need to multiply by 3, so we're going to multiply by 3 on top and bottom. We get 35 over 63, and then 3 times 17 is 51 over 63. And then what's great about that is you've done the hard work. We keep the 63, we add the tops. 35 plus 51 is 86. And that's your answer, okay? And then the next one is division. Now, the division, that is a weird division symbol, but it's a division symbol. Okay, no, that's 3/8 divided by 4. Now, for division, you are going to keep change flip is a silly way to remember. Keep change flip. Is kind of a way to remember the process. So as long as they are looking like a true fraction, not a fixed number, but a fraction, you're going to keep the first number, you're going to change the symbol to multiplication, and you're going to flip the second fraction. And then we can multiply tops with tops, bottoms with bottoms. You can reduce anything that matches on top and bottom has a common factor. But there's nothing that can do that here. So we're just going to multiply tops with tops, bottoms with bottoms. And you get 15 divided by 32. You can't reduce, you can always just reduce later. But that's that. Now, I want to show you on decimals how to do these problems. So if you do 5 divided by 9, and then switch over so it is written as a fraction, plus 17 divided by 21. Now, it gives you a funky answer, but it would allow you to check your work. You might recall, let me go back real quick, our answer was 86 over 63. So decimals now, we can check our work. If we go on a new line and do 86 divided by 63, see how it's the exact same decimal in the answer portion. Okay. Oh, fraction, but I wonder if that will do. I'm sorry. You know what? I don't use decimals as much as my students do. Oh, look at that. So on the left side, there's a little, looks like a fraction with like 2 missing numerator, denominator, like placeholders. If you hit it, it does convert it into a fraction. So hey, that's even better. Okay. And then we could do the other one, 3/8. So 3 divided by 8. And it's scooch over, divided by 4 divided by 5. Now they rate it as a complex fraction. That's okay. Okay. Earlier we got the answer 15 over 32. So we hit that little fraction button, 15 over 32. Perfect. Okay. So we just learned a little bit of some there, hopefully. Okay, let me go back to where we were. Let's talk about exponents. Now exponents, you keep the base when you're multiplying, but you add the exponents. When you're dividing, you keep the base, and you subtract the bottom exponent. Okay. So in this first example here, the bases match a 4, keep the base, add those exponents, and that becomes 4 to the 18th power. Now, this answer is kind of interesting because of the fact that the only common bases are the 3's. We can do the rule that we're going to keep the bases, we're going to subtract the bottom exponent off, so 9 minus 4 is going to become your exponent on the 3. Then we're just going to keep the 5. So our answer becomes 3 to the 5th times 5 to the 7th. Okay. Scientific notation. Remember your front number, your A dot B they have. A has to be a number between -9 and +9. It can include -9 and +9. It cannot be 0. N has to be an integer. A positive integer means that the number is large. It's larger than 10. If it's a negative number, it means it's a smaller number, so 0.00 something. Okay. So it says here to convert our first number to scientific notation. So we want our number initially to look like it's between a -9 and a +9. So we need the decimal to move right there. Now let's count how many places that at. How many jumps? Always count the jumps. So it's 1, 2, 3, 4, 5, 6, 7 jumps to the right. It was a small number. The exponent has to be negative. So it's 5.94 times 10 to the -7. Okay, that negative will move that decimal places back. It's like I divided by 10 again and again and again and again and again. Okay, now let's do the same thing here. We want our decimal to go right there. So -8.752. And then let's count the jumps. So our decimal place should be here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it would be times 10 to the 11th. Now, to multiply scientific notation, we want to multiply the numerical portions. We want to combine the base 10 portions, and then we might have to convert a little bit. Okay. So first, let's multiply the -8.752 times the 5.94. Now remember, a positive times negative is going to give us a negative. So I got -51.98688. Okay. And then our tens. 10 to the 11th times 10 to the -7. We add those exponents. We're going to get a 10 to the 4th. I believe. Let me just check real quick. 11 minus 7 is indeed 4. Okay. I think our answer typed out there is incorrect. Sorry, I am just delivering information. I did not make this document. Anyway, now we want our decimal place. It's too big. 51 is too big. Remember, it has to be between -9 and +9. So we need to bring that decimal place there. So since we moved the decimal place there, that would be a +1, and it would add to the 4 and become a 5. So please make this a 5. And so that's -5.19868 times 10 to the 5th. Okay. So there is a scientific notation problem. Okay. Some algebraic expressions. You need to be able to identify coefficients, define and identify like terms, combine like terms, and evaluate expressions. and you'll have to use order of operations to do that. So remember, our order of operations is, please excuse my dear Aunt Sally, there's pretty much 4 steps to it. You're going to start and do anything that's in parentheses or kind of grouping symbol, parentheses, brackets, or sometimes even fraction verses would do that. Then you're going to deal with exponents. Then you're going to multiply and divide from left to right, whichever happens first. And then finally you're going to add and subtract, whatever happens first. So in this first expression here, I noticed that we have a 12 minus 15 in parentheses. That's the only parentheses I see that is doing anything fabulous. So that would be negative 13. Okay. Now, technically, this is multiplication, this is a multiplication, and this is a multiplication. We kind of have some multiplications there. Anytime a parenthesis touches another item, it's going to multiply by that thing. 3 times negative 13 is negative 39. 6 times 5, it would be technically negative 6 times 5 is negative 30. And here 2 negatives make a positive 35. So all multiplication and division is done. And so now we're going to add and subtract from left to right. Negative 39 and a negative 30 is negative 69 plus 35. Since those are opposite signs, we're going to keep the sign of the larger one and subtract. 69 from 35 is 34. So it's negative 34 is our answer. Now here's the equation. It says, or in equations, we're going to have to be able to substitute, find possible values that satisfy the equation or the solution set, solve equations, and then applications. This is asking, is negative 3 in the solution set? So what we're going to do is we're going to substitute in negative 3. And when we substitute negative 3, and we're going to see if we get the correct answer. So all of the x's need to become a negative 3. So we're going to get 2 times 3 times negative 3 minus 6 plus 4. Does that equal? And I'm going to put a little question mark there. I don't know if it's equal to 12 times negative 3 minus 2. Now let's do each side separately, following an order of operations. We would get 2 times negative 9 minus 6 plus 4, which is 2 times negative 15 plus 4, which is negative 30 plus 4, which is negative 26. So our thought process should be, do I get an answer on the other side of negative 26? Well, I get negative 36 minus 2, which is negative 38. So I can go, oh, no, I do not get a correct solution. I do not get an equation that makes any sense. Negative 26 does not equal negative 38. Now, another alternative is to take that equation, just solve it. If you get an answer of negative 3, then you're good. So if you like to solve equations more than you like to substitute into equations, you can do that. Okay. So let me write this equation over to the right here, a little bit bigger, and so you can do it here. Okay. So anytime you see an equation, first thing you want to do is get each side simplified as much as possible. So we can get the left side can be simplified by using the distributive property, multiply that in. So we get 6x minus 12 plus 4 equals 12x minus 2. We can combine some junk on the left. These are like terms. So we get 6x minus 8 equals 12x minus 2. Now, once you get to the point where both sides are as simplified as far as you possibly can go, then you must start moving things around. So I am going to move the 6x over here, and then I'll move 2 over to the left. Now, the only reason I choose to do that is so that I get a positive 6x here. I get a negative 6 there. And I just like my x to be positive if you can. You don't have to. and then I'm going to divide through by 6, and my x is -1. So the true solution to this equation, or the solution set, would only include the number -1. Some geometry facts you need to know. Now, for the geometry things you need to know, make sure that you know what is the difference between an angle, vertical angle, a 90-degree angle, right angle, what's complementary, supplementary, or complementary, they add up to 90, supplementary angles add up to 180. How does parallel lines and transversals work together? So let me kind of show you what we got here. So we have this picture, and we want to find the measure of all of the angles we see there. So 1, 2, 3, 4, 5, 6, and 7. Okay. Now remember, think about the fact if I chucked this out of the piece of paper, lifted it up, and then set it on top of here, what matches up? That's very important. Now 122 is across. It makes an X with 3. It makes an X there, and then these are on opposite sides of the X. When that happens, that tells us those vertical angles are always congruent, always the same. So this is 122 degrees. Now again, if we do that trick where we pick this, cut out the sheet of paper, and we lay it on top of here, what other ones line up with the 122 and the 3, which is also 122? Well, that would be 4 and 7. So all of these right here are the same measure as long as these two are parallel, and that's the transversal cutting through, which it is. And so this is 122, and this is 122. Now all the other ones, this is what's great, all the other ones create a straight angle with 122, so they're always supplements. They always add up to 180. So to find the other ones, we're just going to take 180 minus 122, which is 58 degrees. So this one is 58, and because this one is across from it, it is 58, and this is 58, and this is 58. So again, 122, 122, 122, 122. Why? These are across from each other. These are across from each other. If you pick these up, they would land on top. They would correspond to the other perfectly. And then finally, we've got 1 and 2 are across from each other. They are supplementary to 122 or 58. 5 and 6 are across from each other. They're the same spot as 1 and 2. They also are going to have to be 58. Okay, so those are very important rules. Draw yourself a little diagram on your cheat sheet. It shows you how those work, because you can see it wasn't difficult. You just have to remember those rules. The word complementary means that two things add up to 90. So the complement of 59, you just take 90 minus 59, which is 31 degrees. The supplement of 59, because they would have to add up to 180, you just take 180 minus 59. 180 minus 59 is 121 degrees. Okay, and so it's just a matter of knowing that language on your cheat sheet. You could write complementary, add up to 90, supplementary, add it up to 180. Those are good facts to know. Okay. Some geometry facts about triangles. A non-right triangle would be either acute or obtuse. Remember, acute it look something like this. All of the angles are less than 90. Obtuse has one angle that has swung a little further than 90. So this one here would be bigger than 90. All of the acute angles are less than 90. Isosceles triangles have two sides that are equivalent. So the two base angles that are across from them would also be equivalent. Equilateral triangles have all 3 sides being the same length and all angles being in the same measure. So there's lots of different things there you can say about those. So let's do an example about some triangle stuff. We know that the two sides here are marked as equal, so we know those two angles are equal. So I'm just going to put marks that look the same on both of those. Okay. So what do we know? Well, this makes a straight line. Straight line is 180 degrees total. So 180 minus 140 is 40 degrees. So we know this is 40 degrees. So this is 40 degrees. Now, a triangle always has to add up to 180 degrees. So we need to figure out, well, what would make this 180 degrees? So 180 total. 180 minus the first 40 minus the second 40, or you could just total those up to 80, would be 100 degrees. So 3 is 100 degrees. Okay. Now, 2 is across from this little wedge, so this is 40. This is a straight angle, so this is 140. So this is across from that, so that is 140. And then I think we have everything marked that they have asked of us. Okay. So you're going to use the straight line to total straight angles is 180 degrees. For vertical angles, if they make an X, these ones are the same. These ones are the same. If you have an isosceles triangle, the two base angles are the same, all those things. Okay. So remember, a right angle is defined as 90 degrees. It makes that perfect L. You do need to know the Pythagorean theorem, which is the sum of the squares of the legs of a right triangle will always equal the hypotenuse squares. So sorry, but if the legs are A and B, then the hypotenuse would always be the larger value C. Okay. So let's look at these examples. It says a right triangle has a right triangle has an angle of 30 degrees. Find the other angle. Okay. So if a right triangle, which one of the angles has to be 90, has an angle that's 30, what is the other angle? Well, these two always have to add up to 90 because this one's 90. Or 90 plus 30 is 120. So it has to always total 180 minus 120 is indeed 60. So that's why we get 60 degrees.
So for this example, we are going to find the hypotenuse of a right triangle with legs 3, 4, and 5. Now, please forgive my triangle making skills. Well, you'll at least get the idea. There's your right triangle. Now, remember, the legs are A and B, and it doesn't matter which you call A or B. I'm going to call the side 3A, side B 4, and C is our hypotenuse. And so that is always going to be the C. So A squared plus B squared equals C squared is what we're going to use. We're going to stick in the A is 3, the B is 4, so 3 squared plus 4 squared has to equal C squared. Now to follow order of operations, we want to do each square. So 9 plus 16 equals C squared. That is a total of 25. And that's what you want to take the square root of. So C is going to be the square root of 25, which is 5. Now, the hypotenuse should always be the longest side. So when you get your answer of 5, since it is the longest side, that's a good indication that we're right. Now let's go ahead. I'm going to copy and paste the next example down here for you. So we have a little bit more room. Now in this time, we want to find the missing leg. So we know the hypotenuse is 14. One of the legs is 8. The other leg is missing. Now it doesn't matter which you call the missing leg and which one you call 8, but we do know that C has to be 14. So I'm going to make A our the one we know, 8, and b is our question. It doesn't matter, the a and b are interchangeable. So I know that 8 squared plus b squared has to equal 14 squared. Now do that calculation. Excuse me. So 8 squared is 64, plus our b squared would equal the square of 14, which is 196. Now you want to subtract off that 64. When you're finding a leg, because it's going to be smaller than 14, you're going to subtract, and you get that b squared will equal 132. So b is approximately the square root of 132, or approximately, when rounded to the nearest tenth, 11.5. And then just take, once we have that value of 11.5, just glance real quick around your triangle. Is our hypotenuse still the longest side? Yes, 14 is the longest side. And that's just a really quick check. Now, for statistics, what are some things that you're going to need to know? You need to know about random samples. So if you want to look at some of the notes about that, you want to look at what are some errors that can happen in sampling and interpreting graphs. You want to know how to make a frequency distribution. You want to know how to create an interpret histograms. So we're going to do all that here. So let's take a look at our first example. It says a nurse is tracking the number of times a patient on her floor press the call button each night, and which number of times occurs the most. So let's interpret what this means. So the number of times is in that first column. So 1, 2, and 3. So 4 times, 4 different nights was 1 through 3. 4 to 6 was 8 nights. And that's how you would interpret down the what the chart means. So you just kind of interpret what that means. So 10 to 12 was 2 times, 13 to 15 times only happened once. So you look for the number of times with the largest value. So you'll notice that 4 through 6 times happened the most. It happened 8 times. So 4 through 6 calls happened 8 times, or 8 nights. Now, this one says, how many times were at least 7 call buttons pressed? Now, if we think about the word at least 7, if I have at least $7, it's 7, 8, or 9, 10, or more. So if we look at the chart, you got to think we're thinking about all 3 of those categories, 7 or more. So you just got to add the number of nights that happened. So 3 nights plus 2 nights plus 1 nights. That happened a total of 6 times. That's just a good way to think about it. Now, this says, what is the total number of nights recorded? Well, that's the frequencies total. So you're just going to take that frequency column, that 4, 8, 3, 2, 1, and just total those out. So it's as easy as that. Just 4 plus 8 plus 3 plus 2 plus 1 is what you're going to do. And that total is 18. Now here we're going to create a frequency diagram. Now, as you can tell, we have one created there, but I want to practice doing it with you if we didn't have that. Now, a frequency diagram is going to count the number of times something happens from least to greatest. So you'll notice that our least amount of times we've seen patients with earaches in a particular maybe day is 2, and our highest number is 8. So then start putting those in order. So you'll notice I have 4 2s, so let me cross those out. And then I have 4 3s on my chart. So I'll cross those out. Let me write those down so we can keep track of them. Now we don't have any 4s on our chart. Let me scooch this over a little bit. So the next highest value is a 5. If you notice in our list, there are 3 5s on our list. So let's cross those out. I'll write those down. We do have a 6. We only have one of them, but we'll write that down next. There are 3 7s. Excuse me. There are 3 7s on our chart, so we can cross those out and write those down. I said the word 3, so I sometimes. And then finally, we do have 2 8s listed. So we'll write those down. And then it's a matter of organizing your data. So once you've put it in least to greatest order, it's very, very helpful to do that. And that's helpful for finding other types of statistical data like mean, median, mode, and stuff like that. So what you're going to do is, make sure you have 17 things on both lists. So you'll notice that we do have 17 things there, and then count how many you have of each. And so then you can make that frequency table. So your earaches would be the thing you were measuring, and your frequency would be on the right. So we have 2 occurring 4 times, 3 occurring 4 times. 4 didn't happen, but you do want to include it. 5 3 times, 6 1 time, 7 3 times, and 8 2 times. And so that's how you can organize the data into a frequency diagram. So it's not a bad thing to do. It's pretty straightforward. Now, this one, we want to create a grouped frequency diagram. So when we create a grouped frequency diagram, we need to know what is our lowest, what is our highest, what's a good breakdown of those things. You usually want to have, in this case, from 2 to 19, we have a gap of 17. And so, you want to probably have minimum of 5, maybe 6 categories. But if you think about 6 um, times 3 is 18, so that's a good one. You should also, you can check how many items are on the list. If you look at how many items are on the list, sometimes that can help you also determine. Sometimes they'll tell you how many different groups you want. So, it's just a matter of, how do we want to organize our data? So we want to group our data um, in intervals of 3, so 2, 3, 4. And then you just start adding 3 to each one of those categories to make the other. So 5 to 7, 8 to 10, and so on. So that would be the number of arm breaks on the left side. And then how many times did that occur? So for the 2 to 4 category, we're going to go through our list and we're going to count anything that's 2, 3, or 4. So I'm highlighting here 1, 2, 3, 4, 5 times that frequency is either 2, 3, or 4. Now we got to count 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7, 8 times. We're either 5, 6, or 7. Let's write that down. Now we are looking between 8 and 10. So not 1, 2, 3, 4. 4 of those are 8, 9, or 10. Now we need to check 11, 12, and 13. There's only one of those, just 12. Now we do 14, 15, 16. I only see 14 and 15 left, so there's only 2 of those. And then finally, our highest value in that 17 to 19 category, there's just 19, so there's just one of those. We need for 14 to 16 was 2, 17 to 19 is 1. And that's it. That's how you create a frequency, grouped frequency diagram. You create your groups. So, here I did 2 to 4, 5 to 7, so on. And then how many times did to that category, anything in there happen? So, you can use how many values and so on. Okay. Next, we're going to do question 6 about a histogram. The histogram shows the starting salaries rounded to the nearest thousand, I'm sorry, to the nearest $1,000 for college graduates based on a random sample of 1,000 recent graduates. Determine which of the following is true or false according to the graph. Now, when I see a histogram, before I actually jump in and read the question, I like to really dive into that histogram. So let me zoom in here for you. Um, so first, it says at the top, starting salaries of recent graduates. Down at our x-axis, we can see the salary is a grouped data between thousands of dollars. So 31 to 35,000, 36 to 40,000, 41 to 45, and so on. And then you got to look at your y-axis. That is the number of graduates or the frequency. Okay. Now, sometimes you might want to actually see, well, what are the heights of the bars? How are they arranged? You'll see we're counting by 50s. So make sure you know we're counting by 50s. And then sometimes I'll even put the guesstimate of what I think it is. So that one looks like it's about 70. That one's maybe 148, maybe 145. Now, this is just a guesstimate. This one looks to be just over 300. So let's go 315. This looks right smack in the middle of 250 and 300. Let's go 275. This one looks right between 100 and 150. So maybe 120, 125. This one looks to be really close to that 50 line. So let's call it 50. And this one looks about 25. So that's just going to help us answer the question. So now it's time to answer the question. If the sample is truly represented, now remember that is 1,000 on that chart. Then for a group of 600 graduates, we can expect how many of them, or I'm sorry, if we have 600 graduates, uh, we can expect about 84 of them to have starting salaries between 36 to 40,000. So let's go with what we know on the chart. 148 out of 1,000 is how many out of 600? Is it going to be that 84? Okay, so we got to solve this proportion. So you're going to cross multiply. So if we do 148 times 600 and divide by 1,000, should we get a number close to 84? And then it would be true. Now, again, my 148 might not be perfect. I got 89, not 84, but I think my 148 might have been a little too high. I said I wanted to get something close to 84 to say it's true. And I believe, yes, it's true because the height is approximately 140. So that answer would be true, not false. So if we change it to 140, you do get exactly the 84 they're talking about. Now, again, I thought it was a little closer to like almost closer to 150, but again, we still got something very close to that 84. So yeah, it's true. Now let's talk about a stem and leaf plot. Now we have these customers. We have this list. You'll notice that they are all two-digit numbers. So for two-digit numbers, using the tens place as your stem and the ones digit as your leaf is a really good way to go. If you were hundreds, you might want to use the hundreds as your stem and the tens and ones um, as your leaf. We need to organize our data. So let's find the numbers from least to greatest and go from there. So my least is 10. I found two 15s. Then I found two 16s. We'll cross them out as we go. We found 18 and 19. And then the next is 20s. Let's see, there's a 22 on our list. Oh, I'm sorry, there is a 19. Okay, there's a 22 on our list. So I'm just going to count them by, put them in the tens categories. Then 27. And then there's a 28. Let's cross that off. Now go to 30s. There's a 35 and there's a 37. Let's cross those off. 40s, there's a 42. And then there's a 46. And then in 50s, there's a 51 and a 58. 60s. We got a 61 on that list, 65, cross those out, and a 66. And then for 70s, there's only a 71 and an 80. Okay. Now, by arranging them by tens, it's very easy to make your stem and leaf. Remember, we're going to make the stem our tens and the leaf our ones. So our tens are 10, 20, 30, 40, 50, 60, 70, 80. It's good to make a little key to explain what it means. So 1/0 would be 10. So we're going to put the tens digits there from 1 to 8 represents 10 to 80. And then remember, even if you have a repeat, you got to show them twice. So if we start with our tens, we have a 0 in the ones digits. We have two fives, two sixes, an 8 and a 9. And then for our 20s, we have a 2 and a 7 and an 8 in our ones digits. Then we have a 5 and a 7 in our threes, a 2 and a 6 for our fours, a 1 and an 8 for our fives, a 1, 5, 6 for our sixes, 1 and 0 for a 7 and 8. So that's how you do a stem and leaf plot. Just organize your data, and there you go. So next, remember, we're going to need to know how to do mean, mean, mode, mid-range, range, standard deviation, all of those things. And we're going to do some of it on Desmos so that you know how to use some of the functions there. Remember, when you take your test, you want to open up the Desmos tab first before you start the actual test. Now, of the list, mean, median, mode, mid-range, those are pretty easy to calculate by hand. Standard deviation is the hardest one to do by hand. So I'm not going to do that one by hand. I am going to show you that one in the Desmos app, but I will show you how to find the other ones by hand. I think everything but mid-range is a function in Desmos you could, because you write out the list once and there you go. Okay. Now, anytime you have a list of data, so these are ages of customers, you need to organize your data. So the first thing I would suggest is to write your data down from least to greatest. So we have 10, 2 15s, 2 16s. We're just going to go down the list. So that's the same list we had used earlier. So let's start with mean. And, you know, always check how many do we have on our list. So we have 22 on our list. I'm sorry, 21 on our list. We have 21 on both things. Let me count one more time. Yes, we've got 21 items. Now, to find the mean, you were just going to take the sum of those things and you add them up. And then you want to divide by how many of those things are on your list. So when I added up the list, I got that my total was 798. And then you divide by 21 things and you get a mean of 38. So I'm sorry that the mean listed there, 38.5 is incorrect. It's 38. There was a few little errors on this list. Now, as far as the median goes, take your 21 and divide it by 2. That's 10.5. So that 10 is really going to show you that we need 10 below it and 10 items above it. Our median is the one smack down in the middle. In this case, 35 is right smack in the middle. Let's talk about modes. Now, modes are the most occurring values on your list. I see 15 twice. I see 16 twice. Nothing else appears more often than that. So we actually have two. You can have no modes or more than one. There's a mode of 15 and a mode of 16. Now let's talk about mid-range. Now there's an error on the mid-range one as well. I'll fix it. You take the highest value and the lowest value, you subtract them. 80 minus 10 is 70, and divide it by 2. In this case, our mid-range is 35. Now the only one I'm going to do in Desmos, but you can do every one there, I think, except mid-range, is standard deviation. So the first thing you're going to do is you're going to hit functions, and you're going to tap on the one that says STDEV for standard deviation. And then you're going to type the list. So hopefully you've had that list written out on your paper. So now you go ahead and type with commas between each item from the list. So that standard deviation may be a little bit off here in this section right there. So there's some of the information you need on your exam. I hope this helps you understand it more clearly. If you need any help at all, please just let me know, and I would be more than happy to help you. Have a great day.